In this video, we are going to discuss number 11. It begins by saying, consider the following probability distribution and the hypothesis or the claim, which is saying the mean mu, the population mean mu, is less than 25. So, as you can see, the data is presented. This is a discrete probability distribution, as we can clearly see. The random variable has values 6, 10, 14, 20, and 24. And the probability values respectively are 0.21, 0.29, 0.11, 0.24, 0.15 respectively. So this is a discrete probability distribution. And the calculations that you see below are to solve or to calculate the population mean, and the two methods for calculating the standard deviation. Now we move on to part A, which says to find the probability of B equal 14. This is not B, this is X. So I think this has to be edited to X. The symbol for the random variable here is X. So the probability that X equals 14, so we look for 14, and the probability value is 0.11. So this is why the answer is 0.1. B, what is the probability that X is equal to 8? So let's see if the random variable X can assume the value of 8. As we can see, 8 is not a value that X can be. Okay, so it is impossible for X to be 8. 8 is not in the table. So therefore, the probability of X being 8 is impossible, which is 0. The probability that X is greater than or equal to 14. Greater than or equal to 14 would be from 14 and anything above. So that's 14 or 20 or 24. And bear in mind, as I said, the word or, we have to add. So we have to add 0.11, 0.24, and 0.15. And that will be the probability that X is at least 14. And that will give us 0.5. Now we move on to part D. It says, determine the mean and state whether or not the claim is true. Okay, the mean here is 14.1. Let's see how this was obtained. Bear in mind, the formula is the sum of X times P. So we need to find X times P. X times P means each X value multiplied by its corresponding probability. So that will be 6 times 0.21, we get 1.26. 10 times 0.29, 2.9. And this was done right up to 24, sorry. And these values were added up: 1.26, 2.9, 1.54, 4.8, and 3.6 to get a value of 14.1. So what you must do is to actually take out your calculator, your pencil, your paper, and actually perform this calculation to prove to yourself that you can actually calculate the population mean if you are given a table like this. Just simply multiply each X value by its corresponding probability and add them up, and this will give you the population mean. Now remember, the claim says that the mean is less than 25, and we got a mean of 14.1. So it appears that the claim is true, that the population mean is actually less than 25, because 14.1 is less than 25. Now part A says to choose a method to determine the standard deviation. There are two formulas to calculate the standard deviation. This formula here says we've got to find P, open bracket, X minus mu all squared. We've got to do this for each X value and then add it up and then square root. So as you can see here, the first P times open bracket X minus mu all squared, here it is, 0.21, which is P here, open bracket 6, which is X here, minus 14.1, which is the mean, close bracket all squared, to get a value of 13.78. And this was done for each x value right up to 24. The p here is 0.15, open bracket 24 minus 14.1 all squared. And these 1, 2, 3, 4, 5 values will add it up. Here it is, they were summed up to give us a value of 14.71, and this was square rooted to give us a standard deviation of 6.458. Now, the second method says that we've got to multiply p by x squared and then add them up. So the first one is 0.21 times 6 squared. Here it is. 0.29 times 10 squared, right up to 0.15 times 24 squared. These values will add it up to give us that value here, which happens to be 240.52 minus the mean squared. Here it is, minus mu squared. Mu is 14.1. And then when these were for 240.52 minus 14.1 all squared, when it was subtracted and then square rooted, we get a value of 6.458. So again, I repeat, you need to take out your calculator, your pencil, your pen, your paper, your notebook, and to perform this calculation to ensure to yourself that you can actually do it. And you've got to do it repeatedly to make sure that it stays as a preparation of learning how to calculate the mean and the standard deviation for a discrete probability distribution. In evaluation, you will choose either one of the methods. But for now, you can learn both methods for security. So it's all a matter of pausing, rewinding, replay, and so forth. Putting pen to paper and doing your calculations. And that's how you practice using this video and also the written solutions as a help to practice